listeners, you are welcome to today's episode where we are going to start a consideration of the laws of mathematical sciences. In our previous episodes, we considered the laws of physical sciences. Today's episode is a continuation of the laws of science. We remember that the goal had always been to consider the three laws, the laws relating to the tripartite structure of this channel. That is to say, the laws of science, the laws of theology, and the laws of philosophy. So we'll be considering the laws of science, and then we started by considering the laws of physical sciences. So today we are starting a consideration of the laws of mathematical sciences. So of course, when we talk about mathematical sciences, we have in mind the fields that are related or that can be described as mathematics, statistics, and computer science. Of course, there are so many laws that can be considered. We cannot exhaust them. Just like the laws of physical sciences, we just pick some fundamental laws. There's no way one can consider all the laws with respect to a particular field. So today we're just going to highlight some of the key fundamental laws of mathematical sciences. And we are going to zero in, we're going to focus on numbers, real numbers, the laws of real numbers. So what do we mean by a real number? Of course, when you talk about a real number, you are talking about a union of the set of integers, set of natural numbers, set of rational numbers, set of irrational numbers. But we are not going to, it doesn't include the set of complex numbers. And of course, a simple example of an element of the set of real numbers, a number is an integer, like 2, 3, minus 2, minus 3. Or it's not a whole number, it's minus 2.3, 3.5, that's a real number. Or a number that can be expressed in the form of A all over B, where your B is not 0, like 2 over 3. That's a rational number, which is also a real number. So, and so on and so forth. So, the real numbers form a very important platform upon which the whole of mathematical sciences is based. The fundamental laws relating to real numbers actually help in solving a lot of problems which arise in mathematics itself and in other applied areas of study. So please sit back and enjoy today's episode where we start the consideration of the laws of mathematical sciences by focusing on the set of real numbers. You have some laws of real numbers, where the symbols X, A, B, C represent real numbers. And we can see the number line here, even though the number line has actually captured the set of integers, where you have the negative integers to the left of 0, this is 0, and you have the positive integers to the right of 0. So, some of the laws, of course, there are so many laws, but some of the laws we just want to highlight include 1, with respect to the real numbers, identity law. Identity law. What this law says is that with respect to addition, given a real number A, that is, any number here, of course, because real numbers we are talking about, it could be 0.2, 0.3, 1.5, minus 3.6, and so on and so forth. That is, we won't necessarily consider numbers that are integers, that are whole numbers. You can consider numbers in between two integers. So given, for the identity law, we are saying that given any number A, any real number A, when you add 0 to that number, we always give 0. Also, if you multiply that number, irrespective of what the number is, once is a real number, if you multiply 1 by the number, you are going to get the number A. The first case, when we talk about addition, is called the additive law with respect to identity. And then the second case, when we talk about multiplication, is the multiplicative aspect of the identity law. So we can consider so many, you can just put in any number and you are rest assured that you are going to get that number. If I put, for instance, minus 2. Minus 2 plus 0 will always give minus 2. Minus 2 times 1 will always give minus 2. Of course, any number multiplied by itself will give that same number. And we explain this property indirectly and directly when we are considering the duality in nature with respect to addition and multiplication. So we can move to the second law, which is the inverse law. As the name implies, the inverse law, of course, for the inverse law also we have the version for addition and we also have the version for multiplication. What it just says is that given any number, any real number, there will always be a number x, another number x, such that when you add that number to A, you always get 0. And that number that you add to A to get 0 is called the inverse of A. So, for instance, if I pick 2 here, okay, so I'm going to look for the number that will make 2 plus that number to be 0. Of course, a simple algebraic manipulation is just put x, make the x the subject of the formula and move it to the right hand side. So x will equal to minus a. So if I pick 2, the x will be minus 2. If I pick minus 2, the x will be plus 2 because minus 2 times minus will be plus. So that applies. If I pick 0.5, it will always be minus 0.5. If I pick minus 0.5, it will be 0.5. So that's what the inverse, and it applies to all real numbers that you can think about. The same goes, we can apply similar procedure to the multiplicative inverse. This one says that given a number A inside the set of real numbers, you can always find another number x, so that when you multiply that x by A, you always get 1. And that number x that you multiply by A to get 1 is what is called the multiplicative inverse. Just as we did with the addition, a simple manipulation of the equation ax is equal to 1 will make us to know what x will be. If we make x the subject of the formula by dividing the left-hand side and the right-hand side by a, so the left-hand side becomes ax all over a goes, remains x here. The right-hand side becomes 1 over a, which is 1 over a. So the inverse we are looking for to, that is the 1 over a, which can also be written in terms of index as a raised to the power minus 1. So that's the identity law, and that is the inverse law. We move to the third law, which is called closure law. Closure law. As the name implies, this law just talks about a phenomenon in which you have the result of the operation you perform is still inside. You have two elements inside a room. And then when you perform an operation on the two elements, what you are going to get will also be inside a room, so to say. So that's the concept of closure. It's like you have closed the door of a room. It's not going to be outside of a room. So, for the addition, closure means if I have two real numbers, A, B, and I add them together, I'm going to have the number A plus B will also be a real number. A is a real number, B is a real number, so addition of A and B will be a real number. So that's the closure property. It is closed. That is, the addition you are going to get is not going to be outside the set of real numbers. That's for the addition. Similarly, for multiplication, if A is a member of the set of real numbers and B is also a member of the set of real numbers, when you multiply A by B, that element will always give a real number. So for all real numbers, closure property is also satisfied, in addition to identity and then the inverse property. We move to the next one, which is the commutative law. Commutative law just says that if you have A is a real number and B is a real number, with respect to the addition, irrespective of the way I arrange it, if I say A plus B must always be the same thing as B plus A. If I put A here, I say A plus B, it's going to be the same thing if I put B here and I put A here. So anytime you have that, the commutative law is said to be satisfied with respect to the addition. For multiplication, it applies similarly. A is a real number, B is a real number. With respect to the set of real numbers, the set of real numbers is said to satisfy the commutative law in the sense that for all elements of this set of real numbers, when I say A times B must always be the same thing as B times A. Just pick any number you want to say. A is 3, B is minus 1. 3 times minus 1 is minus 3. Minus 1 times 3 will be minus 3. So all real numbers satisfy that property that called the commutative property or commutative law. We move to the next one, which is the associative law. As the name implies, there is a form of association. When you talk about associative law, you have 3 elements of the set of real numbers. You can see the way the bracket is. I said A plus, you open the bracket, B plus C. Okay? So, the law allows us, when you open the bracket and you make it A plus B, and then C. Here, we bracketed B plus C, but we are saying that you are going to get the same result if you have bracketed A plus B and allow C to flow, so to say. So for addition, the associative law says A plus bracket B plus C must be equal to, open your bracket, A plus B, close it, plus C. Similarly, for multiplication, A times B will always equal to B times A. It's a very important and universal property of the set of real numbers. The fifth law we want to consider is, we just consider associative law now. So we want to consider the next one, which is distributive law. So just look at the name, it distributes. Okay? In this case, you have A, then multiplied by, open the bracket, B plus C, close it. The law says that A will distribute itself over the elements inside this bracket. So you can say that A in bracket B plus C, bracket close, equals to A times B plus A times C. So when you have such a situation, the distributive law is said to be obeyed, and it is valid for all real numbers. And that's what permits us to factorize expressions. If you have an expression like this, you can factorize, look for a common term, and then you can have this. We move to the seventh law with respect to real numbers, which is called the trichotomy law. You can take note of this part of the word, try. That is, it's talking about three things there. So the trichotomy law simply says that when you have a number A and another number B, and you want to have a comparison between the two of them, you can only have one of the three cases. It's either your A will be less than B, or your A will be equals to B, or your A will be greater than B. We can look at the number line for the set of integers, for instance, which is the subset of set of real numbers. So if you can't have a number, once a number is greater than 0, it cannot be less than 0 at the same time. Once a number is 0, it cannot be another number at the same time. So once a number is less than 0, it cannot be 0, or it cannot be greater than 0 again. So that's what trichotomy law, that it's either a number is less than another number, or is equal to another number, or it is greater than another number. It's a very important property law, which when one is working with complicated cases, you can always use to make inference and decide and get the result to show whether A is less than B, or A is equals to B, or A is greater than B. You know that only one of them must be satisfied. So you can eliminate to the extent that you can now have one result. You now move to what is called the transitivity law. We have used the transitive law one way or the other. We have mentioned it in the course of discussions of this episode with respect to some other considerations. But what the transitive law just says that with respect to inequality, if A is greater than B and B is greater than C, then A must be greater than C. We can just simply look at that and use a simple example to verify that. Let us pick two numbers, A and B, such that A is greater than B, and then we pick another number C so that B is greater than C. So just let's look at these three numbers. 1, 2, 3. So let's say this is A, this is B, and this is C. Okay? No, okay. So let us say this is A, this is B, this is C. A, B, C. So A is greater than B, 3 is greater than 2, and 2 is greater than 1. So we can infer that 3 is greater than 1. It's always going to be valid. So that's what the transitive law says with respect to real numbers. We move to the ninth law, which is addition of a constant. That is to say, given a constant C, just any number you pick, you already have two numbers, A and B. You can pick any number, A and B. It could be 0.1, it could be minus 2.4, and so on and so forth. Now, if I add any number C to A, if A is greater than B, then any number C that I add to A will always be greater than any number, what I'm going to get when I add the number C to B. Because you are adding the same number, the same constant. If I pick, if A is 2, for instance, and B is 1, so we know A is greater than B. So if I add minus 1 to A, okay, I'm going to have 2 minus 1, which is 1. And if I add minus 1 to 1, which is B, I'm going to get 0. So whatever it is, the A will always still remain to be greater than B, and the result of the addition will also be greater than when you add the constant C to B. That is to say, when you add the constant C to A, it will always be greater than when you add the constant B to C. So that is called the addition of a constant, the law with respect to addition of a constant. These laws are really very, very useful in applied problems. They look simple and elementary, but they are found themselves useful in many applications, in many fields. So we move to the 10th law, which is multiplication by a constant. So it's similar to what we treated in respect to addition. You have A is greater than B, and C is greater than 0. So A times C will always be greater than B times C, provided C is greater than 0. If C is less than 0, okay, the reverse will be the case. AC will be less than BC. Let's simply look at that. Let's choose simple examples. A greater than B. Let us say A is 2, B is 1. And let us pick C to be, it must be a number greater than 0. So let us pick C is 2 also. So A times 2, 2 times 2, I'm going to get 4. Okay. B, which is 1, 2 times 1 is going to be 2. So we can see that 2 times 2 will always be greater than 1 times 2. So this will always be satisfied. But when C is less than 0, that is, Z is now a negative number. You know, we pick C here as a positive number. If it is negative, the reverse will be the case. Okay? For instance, let us use the same example. There's the same figures. A is 2, B is 1. But this time around, instead of picking C to be 2, let us pick C to be minus 2. So A times C, A times 2, that will be 2 times minus 2. So that would be minus 4. Okay? B will be 1 times minus 2, which is minus 2. So you can see in this case now, your minus 2 is actually greater than minus 4. Because when you are on the left-hand side of the number line, the values increase as you move away from 0. Also, when you are on the right-hand side, the value increases as you move away from 0. So we have seen that the case when C is negative, we're going to have a reverse situation. AC can never be greater than BC again, to be less than BC. So that's the multiplication by a constant, the law with respect to multiplication by a constant. I believe you have enjoyed today's episode where we introduce the laws relating to the set of real numbers as part of the laws of mathematical sciences. In the next episode, we are going to continue by considering other fundamental laws relating to mathematical sciences. So please stay tuned and be expectant of the next episode. You are welcome. Thank you very much.